Hello everyone, welcome to Shrim's classes. In today's lecture, we are going to discuss exercise 4.2, problem number 1 to 4. So this is the chapter of determinant and this is part of standard 12 textbook NCERT. So we are going to discuss first few problems and we are going to use the properties of determinant to solve this problem. Alright, so before starting the exercise, let's review all the properties in a quick manner and then we will jump onto the exercise. Alright, I will mention as well which all properties we are going to make use of in first few problems, which are going to be 1 to 4 problem numbers, and then we will again revisit those properties as and when it is required. Alright, so let's start with the properties first. So what are the properties? So in your textbook there are 6 properties given. So the first property says the value of the determinant remains unchanged if its rows and columns are interchanged. So if you change rows to columns to rows, then basically if you take the transpose of the determinant, the value of the determinant will remain unchanged. Second property says if any two rows or columns of a determinant are interchanged, then sign of determinant changes. So say if you are changing, R1 to R2, this is how we write, or C1 to C2, these two columns or rows I am taking, the values of determinant will change and there will be a negative sign, right? So this is the property, second property. The third property says if any two rows or columns of a determinant are identical, so two rows or columns, so say R1 is equals to R2 or C1 equals to C2, so then the value of the determinant will be 0. So this is the third property, and primarily we are going to make use of this property a lot to evaluate the determinant. And then the fourth property says that if each element of a row or a column of a determinant is multiplied by a constant k, then its value get multiplied by k. So basically what it says that, for example, if you have determinant like this a, b, c, d, e, f and g, h, I, then if you multiply it with a constant k, the first row, so let's say ka, kb and kc, and then rest of them remain same, d, e, f and g, h, I, then the determinant will be equivalent to delta of a, b, c, d, e, f and g, h, I. Alright, so this is the fourth property. And then a fifth property says if some or all elements of a row or a column of a determinant are expressed as sum of two or more terms, then the determinant can be expressed as sum of two or more determinants. So this property also we are going to make use of to evaluate the determinant, and when I do that, maybe I'll come back to this property so that you can understand this property a lot better. Alright, another final one is the if to each element of any row or column of a determinant the equi-multiples of corresponding elements of other row or column are added, then value of determinant remains the same. Okay, so basically what it says, it's given here that if Ri is any column R1, R2, R3, and if you are multiplying R1 with k times R1 and then adding it to the R1, then the value of the determinant will remain unchanged. And this property also we are going to make use of a lot. So while I make use of that property, I'll come back again over here. Alright. So now let's go to the exercise. The first one talks about there is a determinant x, y, z, a, b, c, and we have to prove this to be 0. Alright. So we are going to make use of a property first. So this is the determinant I have been given, x, y, z, a, b, c, and x plus a, y plus b, and z plus c. So we are going to make use of a property which I am going to remind you about is this property. We are going to make use of the property 5. So what it says is sum or all elements of a row or column of a determinant are expressed as sum of two or more terms, then the determinant can be expressed as sum of two or more determinants. So in words, what it says is, say if you have a determinant like this, lambda plus a, lambda plus b, lambda plus c, and then you have d, e, f and g, h, I, you can express it as lambda times lambda and d, e, f and then g, h, I, and then the plus you will have to write A, B, C, D, E, F and G, H, I. This is what the property is. So we are going to make use of that property. So you can see instead of a row, this is a part of this column. So what I can do is I can write it like X, Y, Z, A, B, C, and then I can write it X, Y, Z and the plus of X, Y, Z, A, B, C and then A, B, C. Alright. So when I sum this and this, I will get this one, right? So corresponding element, this summation of this will, I'll come to get this one, right? Now look at this one. This column is identical to this column, right? So what will be the value of it? It will be 0. And why will that be 0? Because of this property. What it says is this: if any two rows or column of a determinant, if any two rows of a determinant are identical, so the corresponding element same, then the value of determinant is 0. So this is the property 3, and you can see our two columns are equivalent, so this is 0. Same way, now this column and this column, this column and this column are equivalent, so this is also 0. So we made use of two properties in this one, and this is how we got the value. Now I can say this RHS is proved. Alright, now let's go to the second one. My second example is having one determinant like A minus B, B minus C, C minus A and all that, right? So let's write the determinant A minus B, B minus C, C minus A, B minus C, C minus A minus B, C minus A minus B and B minus C. This is my determinant and this is my LHS actually, right? Now what I can do this. I can write column C1 equals to C1 plus C2 plus C3, okay? And so what I've done is I've made use of a property 6, which says in words, it says that if you multiply, if to each element of any row or column of a determinant, the equi-multiples of corresponding elements of other row or column are added, then the value of the determinant remains unchanged, right? So this property I am going to make use of, though it is talking about only one particular column, but we can actually extend this argument and then do this one, right? So this is my property 6. I'm just writing so that you can just revisit your property. Now what will happen to this determinant? The value of determinant remains unchanged, but when you sum this one with this one, you will have A plus B plus C and then minus B minus C minus A. So okay, let's write at least one. A minus B plus B minus C plus C minus A, and then another one B minus C plus C minus A plus A minus B, and then third one C minus A plus A minus B plus B minus C. Alright, now the other ones are B minus C, C minus A minus B, and the other one is C minus A minus B, B minus C. Alright, now you see that this is cancelled out, this is cancelled out, this is cancelled out. Same way, this B is cancelled out, this A is cancelled out, C is cancelled out, C is cancelled out, B is cancelled out, A is cancelled out. So the what we are getting over here is we are getting 0, 0, 0 over here, and B minus C, C minus A minus B, C minus A minus B, and B minus C. Since these three are 0, basically these three elements are 0, the value of determinant is 0. Alright. So yeah, this is the second one. Now come to the third one. Now third one is having numbers. So you have got numbers and you have to observe it closely. So 2, 3, 5, 7, 8, 9 and then 65, 75, 86, right? Now in this one you have to observe it very closely and we have to prove it to 0. So looks like there will be one property which is going to be used. Maybe either the columns are going to be same or the rows are going to be same, right? So what we will do is we will observe this 65, 75, 86 closely and this one closely. So just look at the numbers here. If I can just multiply 7 with 9 and add 2 to it, what will I get? I'll get 7 into 9, 63 plus 2, 65. Similarly, 8 into 9 plus 3, if I do, what I'll get? 8 9s are 72 plus 3, 75. And the third one, 5 into 9, 9 into 9, 9 into 9, I'm multiplying 9 into 9 plus 5. So it will be 81 plus 5, which will be 86. So looks like if I can just write C2 equals to 9 times C2 plus C1, right? Then the value will become what? So let's do this. That will become 2, 3, 5, and then this will become, as we did, 65, 75, 86, and 65, 75, 86. So which property we have made use of here? We have made use of property 6. Property 6 of this one. So what is the property here? It says again the same thing. If to each element of any row or column of a determinant, the equivalent multiples of corresponding elements of other row are added to the value of determinant remains unchanged. So this is what we have done. As you can see, Ci plus KCi. So what we have done, we multiplied with 9 and then we have added another column to that, right? So now again another property is these two columns are same. So the value of determinant will be 0. Why? So two columns are same, right? And which is this property? This property is your property, basically third, right? Yeah, this is the property 3, right? So just go and revisit your property 3 and you will be able to see why the value of the determinant is 0. Okay. Now coming to the fourth problem. My fourth problem is having one more determinant and we have to prove it to 0. So let's write LHS. So again 1, 1, 1, BC, CA, AB, and then A, B plus C, and B, C plus A, and C, A plus B. Again, whenever we have to prove it to 0, we know that there could be something which the two columns would be becoming same, right? So now let's do it again over here. If you can look at column C3, if I just do a C2 plus C3, what will happen to this column? So let's see, if you do C2 plus C3 over here, so what you will get, and we will just write it out, right? So we will write 1 BC and then it will become AB plus AC plus BC, and then the second one will become 1 CA and then it will become BC plus BA. So what I am doing, I am just multiplying this first and then adding it plus CA, and then third one will become 1 AB CA plus AB, alright, CA plus CB, CA plus CB, right? CA plus CA plus CB, CA plus CB plus AB. Okay. Now look at this one, AB, AC, BC. This is also AB, AC, BC. This is also AB, AC, BC, right? So can I take AB, BC, AC common out? So AB plus BC plus AC, I have taken it out and I can write it as 1, 1, 1, BC, CA, AB, and I can write it as 1, 1, 1. So here I have made use of property 6, right? And this property is what there is a common constant, I am taking it out. So what will happen is that I can just write it as A to delta, right? So which property is that? If you look at the property, my property number, my property number 4, if each element of a row or column is multiplied by a constant K, right? So what happens in this one, there is a constant multiplied, right? So what we are treating here it as that AB, BC, AC is having 1 over here, 1 over here, and 1 over here, right? And so this is a constant which is getting multiplied by it, so I am taking it out, right? So this is my property number what? So I'll just mention so that you can just go and revisit. So this is my property number 4. So you can go and revisit this property, and because of which I have got this one, right? Property number 4. Now again you can see here there are two columns which are similar, right? Now the value of this will become 0 again, BC plus CA into 0. Why? Because two columns are same, right? And you know which property is that, right? Because of which this entire thing will become 0 and then my RHS is proved. Okay. Alright. So yeah, you've got to do a lot more problem to this to ensure that you have kind of remembered all the properties, right? Don't have to remember, you just have to keep doing multiple problems and then it will come easily to you. All right. Yeah, so that's all I had in this lecture. What I'll do in the next lecture is I'll again try to tackle some more problems. If you have any questions in this exercise, please do ask me in the comment section below and I'll be happy to answer your queries. Also, please subscribe to my channel if you like my videos and it keep inspiring me to create more videos. Thank you once again for watching this video. Have a wonderful day.